let's start. So each harvest is different and has its own challenge. For example, this year, some winemakers had to face strong heat waves, followed by rains, for example, which have resulted in unbalanced wines with rather high pH and low acidity, or high alcohol levels, or even both. So this webinar can help you to better understand how to rebalance the mouthfeel of a wine, or at least better understand its components. Balance is often considered as a sign of quality wine by consumers, but why is it exactly? It's a notion that is not very objective. To me, it's a very subjective and not really universal notion. It's more a matter of creation and sensation than of technique, but everyone will agree on different conclusions when it comes to defining what a balance is. But there are some rules and some principles we can actually follow. So that's the idea of today. Let's get started. So through this presentation, the idea is not to give you a recipe or to achieve a specific mouthfeel or balance, but rather to understand together what is considered as a balanced wine and to study the interactions of the components of the mouthfeel. So then secondly, we will see what tools we have at our disposal to adjust a wine with a focus on aging and bottling. So we will see how to use polysaccharides and tannins to balance a wine or to adjust the mouthfeel. And finally, we will see how to set up a bench trials in an easy way, and we'll close the talk with question and answers. So the term well-balanced is commonly used to describe wine, but what exactly does it mean? So every wine tastes different to everyone, but where there is a harmony of different compounds, there is good balance. So balance is something you can create or help to create. Not all the wines have the same consumption objectives, so the balance of a wine will be very different if the wine is consumed within a year or if it ages for another 5 years, for example. So when we talk about wine, but also when we talk about food or beverage, we first speak about the taste, which refers to sweetness. So in wine, it will be sweetness from sugars of wine or polysaccharides, saltiness, usually from the soil, from the terroir, or minerality, or from the mineral salts of wine. Bitterness that comes from the phenolic compounds, sourness, acidity from the acids, and umami from the glutamates. This is this sensation of very nice glutamate sensation. And in another hand, wine balance or wine mouthfeel refers to the harmonious interactions of the different compounds of wine, such as that juggling with water, alcohol, polysaccharides, acids, or phenolic compounds. So this balance of these 5 components can be influenced by several factors, including the grape variety, the location of the vineyard, so the terroir, the winemaking process, and the aging process. A well-balanced wine is one in which none of these compounds dominate the others. So for example, a wine that is too acidic or too tannic can be perceived as unbalanced, while a wine that is too alcoholic or too sweet can lack of complexity of depths. Of course, it's still a perception and a sensation that is subjective for people. So in general, the mouthfeel or the body of a wine comes from the interaction between the phenolic compounds, the acidity, and the sweetness or the viscosity. Together, these 3 elements create a unique mouthfeel, as you see in this triangle. So here are the different wine mouthfeel that are interacting together and that can have a positive or a negative impact on each other. So for example, alcohol. So alcohol, especially when it's higher than 14 degrees, can increase the sensation of sweetness of wine because the fermentation will release more mannoproteins and increase the sweet perception. But in another hand, when it's unbalanced or when it's too much or the concentration is too high, the wine could be unbalanced by adding more hotness sensation or more dryness, astringency. Same with acidity. It can have a very good impact on white rosé or on red by brightening the fruits and the freshness. But it can also have a negative impact if the pH is too high, then you're going to have fewer aromas. Wine that is considered as flabby. Same with phenolic compounds. It's always finding the great balance between enough phenolic compounds to get enough structure, roundness, and a little bit of astringency depending on the wine, but not enough phenolic compounds can be also harmful for the wine because it's lowering the redox potential. Same idea with the Mannoprotein or polysaccharides that gives a great roundness, volume, and body. But too much of these can actually create a very heavy wine, too buttery or too big. So as you can see in this table, there are multiple factors that are impacting the mouthfeel in a positive or a negative way. In fact, this is even more complex when we speak about balance, because we also need to include the brain perception of the wine with the color, the aromas, the flavors perception that have a big impact of the perception of mouthfeel. This is a very important and interesting topic, but that's not the topic of today. So let's go back in the mouthfeel component. So firstly, I wanted to speak about the polysaccharides. So to have a good balance, we can juggle between the acidity, the tannins, and the polysaccharides. So these three components play together. For example, if you want to add more tannins or if you want to remove some tannins, it's still possible. Also with the acidity, it's quite simple or basic. So it's basically removing or adding tartaric acid or lactic acid. And let's start with the polysaccharides to see how they interact and what they are actually. So polysaccharides in wine are polymers of sugar or uronic acids. They are found in large concentration in wine. The main polysaccharides are the pectic polysaccharides from the grapes, and the second family are the mannoproteins from yeast that we see in wine. These macromolecules have many applications in winemaking. They act as protective colloids, so they contribute to wine stability. But they also can reduce astringency, hotness perception. We'll see that a little bit later in the presentation. They increase the viscosity of wine. So about the origin of the polysaccharides found in wine, the large quantity, they are generally part of the pectin category. So they impact the viscosity of wine. Usually to extract them, we use pectolytic enzyme on must. Second family are the mannoproteins. So they are part of the yeast walls of the yeast. So they are found in large quantity and they are released during autolysis and aging. Arabic gum is also a polysaccharide that we can use in winemaking as an additive. So this component is a big macromolecule extracted from the acacia trees in North Africa. Second, polysaccharides, exogenous polysaccharides that we can see in wine are the one extracted or released from oak. So when you age wine in barrels, or when you add chips or staves, some polysaccharides from the wood, from the oak, are released in the wine. That gives this sensation sometimes of roundness, viscosity, sweetness. And finally, that's polysaccharides that we don't really want to see, as they are glucans from Botrytis cinerea on grapes. So they can have a very bad impact on filtration at the end of the winemaking. So we are trying to avoid them. So the content of wine polysaccharides mostly depends on the grape variety, the maturation, and the winemaking process. So today we're going to mostly focus on yeast mannoprotein and Arabic gums, because they are the tools that we can actually use during aging or pre-bottling to play with the wine balance and the mouthfeel. So let's focus a little bit more in the role of yeast mannoprotein in winemaking. So a study of Vidal in 2003 showed that mannoproteins represent 35% of the total polysaccharides in wine. They are part of the architecture of yeast walls, especially Saccharomyces cerevisiae. So they're extracted during autolysis from the beta-glucan enzyme, and they're released. It has been seen since ages, the stabilizing effects of the mannoprotein. Indeed, because when you have a wine that is aged on lees, the lees releases mannoprotein, and that help the wine to stabilize the color. So for also tartaric stability and mannoprotein stability. And you also observe that sometimes it softens the tannins and give a better perception of the sweetness, and many other interesting things like this. So there is a great diversity of mannoprotein with different effects. So the first effect is thanks to the protective colloid action of this mannoprotein. So it helps to stabilize the color, also to inhibit the crystallization of tartaric salts, so help to stabilize against tartaric instability and prevent any protein instability also. On sparkling wines, we also found that the presence or the addition of mannoprotein will help to improve the foam stability and the fineness of bubbles. Same with aromatic persistence. It helps to get a better aroma and in a longer time. It also reduces the astringency and the bitterness, and increase the volume and the softness sensation. So this great diversity of mannoprotein is showed in this table. So every mannoprotein doesn't have the same action. So on this table, you can see the impact of adding 2 different types of mannoproteins extracted from different type of yeast. So first, the gelatin index represents the level of astringency. The higher it is, the higher you're going to perceive astringency. The PVPP index represents the color stability, and the ethanol index represents the sweetness. So you can see that the second mannoprotein has a very significant impact on the reduction of astringency, but also you'll have a better color stabilization and a better sweetness perception of the wine compared to the control and the first mannoprotein, the ADY1. So not every mannoprotein will have the same effect. We worked on our side with Lamothe-Abiet to produce Mannoproteins with specific effects, and we obtained actually 2 types of pure Mannoprotein for 2 distinct effects. So the first one, it's called the STAB-K. It's a pure liquid Mannoprotein used for tartaric inhibition and color stabilization. It's called STAB-K. And the second one that is interesting us today is called the MannoSense for its organoleptic impact. So MannoSense is a liquid solution of Mannoprotein rich in HSP12. So the HSP12 peptide is very interesting for us. It started with the thesis of Axel Marshall in 2010. So he found that the HSP12 peptide was released from the yeast in specific conditions. And this peptide is very interesting because it's responsible for the sweetness sensation in dry wines. So knowing this specificity, we developed MannoSense, which is a Mannoprotein with a great impact on mouthfeel and sweetness, and in this sweetness perception, thanks to the richness in this HSP12. So adding this kind of Mannoprotein, this polysaccharides on wine during aging or pre-bottling, it will help to get a better roundness and a better volume. Same with the length in the mouth and an aromatic perception. Also, it can help to get a better foam in sparkling wine. And also it reduces the bitterness and astringency. So MannoSense mostly work on the mouthfeel. As you can see on the graph, on the chart, these products basically enhance the perception of sucrosity, sweetness, but also balance and freshness in wine. So this product is totally filterable. You can use it up to 2 days before bottling, from 50 to 100 milliliter per hectoliters, just before the final filtration. Secondly, another tool that we can use is Arabic gums. So as Mannoprotein, Arabic gums are very versatile. We have a lot of different types. Firstly, to show you the effect of Arabic gum, I wanted to show you this study done by Benoit, comparing polysaccharides and their interaction with tannins and their perception of the palate. So the perception of the palate of tannins, we will call that the dissociation constant. So in our mouth, we have salivary protein in our saliva that will react with tannins. That's the dryness sensation, the astringency that we have. So this saliva protein plus the tannins are gonna precipitate, and it's creating a complex that is not soluble. So that's what you see in this drawing. The P is the protein, salivary protein, and the T are the tannins. So once we add a polysaccharides, so that's the C on this drawing, there are 2 scenarios possible. So in the first scenario, it models the interaction between the salivary protein, the P, and the tannins. And the addition of the polysaccharides, symbolized by the letter C, will coat the tannin protein complex. So that helps to not perceive any astringency, thanks to the addition of this polysaccharides that is actually coating the complex. On the second scenario, there is a stronger affinity between the tannin and the polysaccharides, leaving the protein alone, so no reaction and no astringency perceived in the palate. So with these 2 scenarios, so Faury studied the reaction of the different polysaccharides, such as glucose, pectin, and Arabic gum. And what we see is that the Arabic gum has a lower dissociation constant So the lower the number, the higher the link between the polysaccharides and the tannins. That means the lower perception of astringency you'll have. So as you can see, glucose and pectin have a higher dissociation constant. That shows that you will need to add way more of these compounds to get a similar effect on the mouthfeel that you could have with the Arabic gum. So this study confirmed that there is a direct interaction between Arabic gum, pectin, glucose, and the tannins, leaving the salivary protein alone. So you lose this dryness and astringency sensation in the mouth. We also see that the Arabic gum has the strongest affinity. So so we don't need a big quantity to reduce astringency in wine. So thanks to this study, we can prove technically and scientifically prove that Arabic gum contribute to the body and to the mouthfeel of wines. But on the market, there are two types of Arabic gums. The first one is from Acacia Verrec. So the Arabic gum from Verrec has a protective colloid effect. That means that we're going to use this type of Arabic gum only for its stabilizing effects. So this type of gum will prolongate the stability of the coloring matter, will help to stabilize the protein. It also prevents any metallic breakage, and when you use metartaric acid, it improves the effect of it. Second family is the Acacia Seal, which has this coating power. So this is only used for mouthfeel impact. So to decrease the astringency, to get a better richness and softness in a wine. So the different types of Arabic gum can vary a lot according to their family, but also to the producer, the sourcing. So you can see a lot of different types on the market. So the one we have in Lamothe-Abiet, we developed SUBLISENSE. So it's not only an Arabic gum, it's actually a mix between a Mannoprotein and an Arabic gum. So we wanted to create this blend especially to improve the mouthfeel of wines. So it's a mix between Mannoprotein and Arabic gum from Acacia Seal. So this product is the most versatile for the mouthfeel enhancements. So if you gain in terms of flavor, smoothness and length in the mouth thanks to the Mannoproteins, but also you're gonna reduce the astringency sensation, as you can see in the two drawings. So those two products, so the MannoSense and SUBLISENSE are totally filterable. You can use them from 80 to 200 milliliters per hectoliters, and it has a long-lasting action. We are happy to give you samples of the two products if you want. So second part of the presentation, if we go to the next category, it's about the family of tannins. So phenolic compounds are a very big family of molecules found in wines. And if we focus on tannins, we will see that there are a lot of different types of tannins in wine, and that are actually available for the winemakers. So let's go a little bit deeper into the categories of tannin to help you to choose the good ones for your wines. We can separate the tannins in two big categories. Firstly, we have the hydrolyzable tannins. If we talk about the hydrolyzable tannins, we're talking about first the gallo tannins and the elagic tannins. So tannins that are extracted from oak trees or chestnut trees, the gallo tannins. They have a very strong antioxidant effect, but they are also used to balance and buffer the redox potential, especially because they also have the ability to react with sulfur compounds. So it's a nice tool if you want to fix any reduction. So if you want to limit of aromas linked to reductions, for example, the gallo tannins or ellagic tannins from oak are a very good tool. Then we have the gallic tannins. So they are the most reactive tannins with protein. They are used as antioxidant and antioxidasic. So that means they inhibit the enzymes such as the PPO and lacase that you can find on grapes. So they also can be used as sacrificial tannins because they react a lot with proteins. So they will protect natural phenolic compounds and color of the grapes. So, and also we can use the gallic tannins on white wines to react with the proteins on white. So you'll be able to use less bentonite to prevent protein haze. So second family is the condensed tannins. So firstly, we have the tannins extracted from grapes. So we find this proanthocyanidin tannins mostly in the grape skin and the seeds. They are very soft tannins. We use them for color stabilization, but also mouthfeel to give a better mouthfeel. It gives a full sensation in the palate. And second family, so as you can see, they have very similar molecules. They are the condensed tannins from quebracho or mimosa. So they also can be used for color stabilization because they can polymerize with tannins from grapes also. We use them also for their antioxidant action, and their polymerization. So all these tannins can be added to the wine, but they have different actions. So we don't use all of them for mouthfeel and for aging or pre-bottling addition. So to let you see that, just to summarize the tannins that can be used in winemaking, usually, so the antioxidant, antioxidasic, and protein removal tannins are used at the beginning of the process or during the harvest to protect the grapes efficiently. And also because these tannins are reacting a lot with the proteins, so they are very astringent. They react also with the salivary proteins. So it's better to use them at the beginning of the process. And then the tannins that will be used to stabilize the color are used during the fermentation or early stage of aging to stabilize the anthocyanins. And the ones that are interesting us today are the tannins for aromas enhancements. So some tannins from oak, for example, or balance the mouthfeel. So these tannins will be used during aging or pre-bottling to help us fine-tuning our wines and adjusting the mouthfeel and aromatic expression. So the Lamothe-Abiet toolbox. So we call it a toolbox because there are not tannins that are systematically used. They are rather used in a specific condition or in a specific need. It's great for you to know that they are existing. But for example, if you have a wine that needs a little help in terms of mouthfeel, structure, or if you want to fix a reduction or oxidation, you can use them. Or it's also nice for you to know that to know how they work. So we have three big families of tannins in our toolbox to use during aging or before bottling. I will go a little bit deeper into these three families in my presentation. So the first one is the VINITAN Advance, which is a pure grape tannin that will help for color stabilization, and at the beginning of aging, it will improve the structure, the overall structure, and the aging potential. So, for example, with Pinot or with grape varieties that have a lower amount of phenolic compounds, that can help to give it more tannins and more structure without any astringency. Then we have the SOFTAN FINITION. So SOFTAN is a specific type of tannin because it's blended with polysaccharides. So you'll have the effect of the tannins, but also the effect of polysaccharides. And then we have a range of oak tannins that are called the TAN&SENSE, that are pure oak tannins. So firstly, VINITAN Advance is a tannin that can be used on any type of wines. So from white, rosé, red, or even sparkling. It's highly concentrated in oligomers, so it's very antioxidant and has a very low amount of acid phenols, which are the precursors of volatile phenols from bread. Early in the process of aging, you're going to increase your color stability, the phenolic potential. So you're going to have more matter to age and to support the wine. So a better phenolic potential. And also, it's weird to say it, but actually adding this tannin will decrease the astringency. So on this graph, you can see that the addition of VINITAN Advance, so 10 grams and 5 grams, decrease the SPI, which is the astringency perception, the salivary protein index. So the more you add some, the less you're going to have astringency perception. This measurement has been done a week after the addition of the two tannins. So in terms of application, you can use it during the pressing for color stabilization, or during aging for the structure and aging, or pre-bottling to fine-tune the mouthfeel. Second tannin I wanted to talk about today is the SOFTAN FINITION. So it's a mix, an association between oak tannins and polysaccharides. So it's a complex tannin, multitasking. It will decrease the astringency, but also thanks to its composition and aromas, you'll also have a little bit more complexity thanks to the aromas. And also, what is very interesting and has been interesting for us, that it also reduces the perception of aromas. So it has been a great tool to decrease smoke taint perception in wines, and also volatile phenols from bread. So this graph shows a study made on a lot of different wines. So it shows the sensory thresholds of volatile phenols from bread. So basically, by adding SOFTAN FINITION, in all these wines, we always increase the sensory thresholds of wines. So that means that we perceive less the phenol volatiles aromas when you add the tannin. In terms of dosage, you can go around 3 to 10 grams per hectoliters. I would rather use it at the end of aging or before bottling, same up to 2 days before bottling. And then here are the TAN&SENSE tannin. So we have 4 of them in our winemaking tools, Lamothe-Abiet. So I wanted to show you how we selected and extracted the TAN&SENSE tannins, because it's a bit specific compared to other classic tannins on the market. So first of all, we select and season the oak logs. The oak trunks are selected and then cut into chips and toasted according to the required product, to the required heating. And then the specific part of the process is the way the tannins are extracted. These tannins are extracted by a cold membrane purification without any contact with oxygen. So generally, tannins are extracted with water or alcohol, which will decrease their aromatic power and can also increase their astringency. So thanks to the specific extraction, we can have the maximum preservation of the aromas and high quality of tannins without the astringency. So that means that you will have the high quality of tannins without having to add a big quantity. So this kind of tannins, we suggest using from 0.5 gram per hectoliters on whites to 5 to 10 grams. So with these different tannins, we can work on the mouthfeel at different levels. So first we have the Tannin-SENSE volume, which is an untoasted French oak tannin. So it doesn't impact, it doesn't give any aromas, but it will be a very good help if you have any redox issue. So if you have some reduction aromas, it will help to decrease this reduction, but also same with oxidation. So it's basically a good way to buffer the redox potential, to add a little bit more of volume, texture, and it will boost the fresh fruit sensation. Secondly, we have the Tannin-SENSE origin, which is a light toasted French oak tannin. This will have a very big mouthfeel impact in terms of creaminess, sweetness, roundness, with aromas such as vanilla, coconut, caramel. So it's nice to add it as a last final touch when blending or before bottling, if you want to have this roundness, or if you want to feel the meat palate. Then we have the Tannin-SENSE expression, which is also a French oak tannin, medium toast. So you'll have more structure, a little bit more volume, and the aromas will be different. So you're going to have more toasted almonds, cocoa profile, and a nice length in the palate. And finally, in the range, the Tannin-SENSE range, we have the Tannin-SENSE Forte, which is a high toast. So this is a nice tool if you need more structure, or if you want to get more freshness. So for example, if you have a flabby red wines, or if the aromas are a bit overripe, that helps to give it more complexity, and length in the palate to the wine. So here is a diagram to summarize the different products at Lamothe-Abiet to adjust or play with the balance and the mouthfeel of wine. All these products have a different impact of wine, as you can see. So all of these products are easy to use. They have a direct effect. and are efficient in lower concentration. So you'll also find all this information in our brochure or in our website. So finally, after observing what you needed or what would be nice for your wine, it's important that you make the right decision when if you decide to add something to balance your wine, and we are here to help. So bench trials are important to determine the proper dosage and to validate the treatment before applying it to a larger volume, so to a tank or to a big lot. So to best decide on the right treatment for the wine, we recommend bench tasting with many of our products, such as tannins, the polysaccharides I presented you, but also fining agents, because fining agents can have a nice impact to reduce phenols, compounds, or tannins, or to give more roundness. So here is written how you could easily do a bench trial. Everything is also on our website. And also, we also provide finishing kits, so these little samples. So we can come to your winery to do tasting with you. You can call your rep. You can also send us some wine samples, and we will be happy to taste your wines and work on them.